Okay, today we're going to talk about quadratics and some of the vocabulary words that goes along with it. We've already done quadratics, we've graphed them, we've factored them, but up until this point we've only graphed them in vertex form when you could pull out HK. And now we're going to look at them in standard form, which is y equals ax squared plus bx plus c. And as you know, the graph of a quadratic is U-shaped, and we call that U a parabola. So if we look really quickly at the parent function here, that's the function without any shifts. We can make a little xy chart to see what this does. If x is -2, we'll have y equals -2 squared, which is +4. Okay, if we look at -1, we get 1, and at 0, we get 0. So if we look at a quick sketch of that, and then we mirror it to the positive side, there we have our U shape, and this is what's called our parent function. It is centered here at 0, 0. The vertex is here at 0, 0. It has not been shifted anywhere. So again, that's called the parent function. Okay, now we're going to graph something a little bit more complicated on this graph, just so that we can find and apply some of our vocabulary words. So I'm going to go ahead and draw a parabola here. So there it is. So I drew that beautiful parabola. I don't know what the equation is. It doesn't matter. I just want to use it to get through some of this vocabulary. Okay, so the first piece of vocabulary we're going to hit is the vertex. Okay, as we've been doing the vertex up until this point, we've been using HK, and everything's always been in vertex form. That's going to change, but right now we just need to know that that's the lowest point in this scenario, the minimum in this scenario. If we flip the graph upside down, it'll be the highest point or the maximum. So the vertex is always a point, HK, XY, whatever, it is a point. Then we have this thing called the axis of symmetry. Symmetry means the same on both sides. If something is symmetric, it's the same on both sides. So there is this, imaginary line down the middle of this graph in which we can mirror one side to the other. This picture is exactly the same. If you were a better artist than me, it would be exactly the same on both sides of this axis of symmetry. And sometimes we abbreviate this, the AOS, the axis of symmetry. That's always a vertical line. See how this goes up and down? All of our U's, no matter where they are, will have an axis of symmetry that's a vertical line, so it will be x equals some number. In this case, -2. So these will always be x equals some number because it's a vertical line. Then we have these things we've talked about before called the x-intercepts. We've learned they're also called the solutions. They're called the roots. And if you go to find them in your graphing calculator, you go to second calc and you go to 0. They are also called the zeros. All those words are fairly interchangeable, and those occur where this crosses the x-axis. So these points here are the x-intercepts, or the roots, or the zeros, or the solutions, whatever you call them. Those are the x-intercepts right there. And they are always of the form something 0, because they are where y is 0. So these are always of the form some number, comma, 0. Then we have the y-intercept. So I'm going to flip to, let's go orange here, and let's find the y-intercept. The y-intercept is where the graph crosses the y-axis, which is this up and down axis here. So here it is. This point right there where the graph happens to go through the y-axis is called the y-intercept. And that will always be the point 0 something. So that will always be 0 some number. And let's see, why does this say 0c? Well, if you go up to the standard form here and you plug in 0 for x, you're going to get y equals A 0 squared plus B times 0 plus C. So we get 0, 0. So the y-intercept is always that last thing there, kind of like your B is your slope, and your slope-intercept form is your intercept. So if you plug in zeros there, you're always going to get y equals c. So that's kind of a quick little shortcut. All right, and then we've learned that the value of A determines whether or not the graph opens up or down. So A, this number out front, determines whether the graph opens up or down, and hopefully we're good with this. If A is positive, it opens up, and if A is negative, then the graph opens down. Okay, so again, here's your C, the y-intercept. I forgot to change up my colors there. And A tells you opening up or down. This is the basics of everything you need to know for right now about quadratics. All of these vocabulary words are really, really important, so make sure that you know these. Okay, at the bottom of this page in your note sheets are just a couple of functions, and we want to determine if these are quadratics or not. Okay, so, and then what we're actually going to do once we determine if they're quadratics or not is we are also going to determine if it opens up or down. And we're going to determine the y-intercept, just so that we have a little practice with that. So, number one, is number one a quadratic function? And absolutely no, it is not. Hopefully you know right away. This is standard form of a linear function. That is a line. That is not quadratic. It is linear. Okay, number two, x squared minus 3x minus 9. So our quadratics right now are in the form y equals ax squared plus bx plus c. We've also seen quadratics in vertex form, which is a x minus h squared plus k. So we always have an x squared, which we do here, which is great. So yay, number two is quadratic. Number three has an x squared, so woohoo, that is also quadratic. Okay, number four, that has an x squared, but it also has an x cubed. So this is not quadratic, and it's actually a cubic function because of the x cubed. Number five, well, that has an x squared, but it's not quadratic because of these things, which we know are an absolute value. So that is an absolute value function. That is not quadratic. So we have two quadratics here, and we want to determine if they open up or down, and then if, or what the y-intercept is. So, do they open up or down? Number two, we are looking at A right here. It is a positive 1, and so this opens up. Number three, we're looking at A right here. That's a negative 6, therefore this opens down. And now we want to find the y-intercept. If you recall from the last slide, we talked about the y-intercept being where x is 0. And I gave you a little shortcut that it's always going to be c. So let's look at that from both ends there. So the y-intercept is where x equals 0. So on number two, we have f of x, or f of 0, equals 0 squared minus 3 times 0 minus 9. So essentially, y equals negative 9. So the y-intercept here is 0, negative 9. C. The y-intercept here on number 3 is where x is 0. So we have y equals negative 6 times 0 squared plus 1. This is 0. Y equals 1. So we have the point 0, 1. Or again, C. Okay, so the next two pages in your packet follow this introduction to quadratics. It's just looking at the graphs, matching things up. Keep this page here handy if you need it, and we'll talk about it later. Have a great day.